Hey folks, this is Nick from Tectonic Tribes. In this short video I just wanted to explain what combined heating and power generation is. And I'm going to use this very simple diagram of a building. In this particular case it's a home. And most properties have a supply of gas and electricity. Gas being typically used to supply power to a boiler for heating inside the building, and electricity being typically used to power appliances, which could be cookers through to televisions and other similar electronic components. Now what we've got here is obviously two energy sources and two systems, and the efficiency of this is obviously greatly reduced and requires more equipment to do the same job. And interestingly, because there is some chemistry and mechanics going on here, there's always some output of some alternative type of energy. So for example, electricity due to resistance gives off some kind of heat. Gas, for example, depending on how it's processed and in what type of system, can be used to generate both heat and electricity simultaneously. And in fact, that is what's happening in a combined heat and generation unit. And typically these things are powered by a device like a fuel cell, which converts a fuel into some kind of energy. And that energy is typically electricity. One of the byproducts of electricity, because it's a chemical reaction, is heat. So instead of just dissipating that heat, in other words throwing it away, what we're doing is we're turning that heat into a usable energy source to heat the building. So now instead of these two separate units, it's possible to have a single unit that supplies both the heat and the electricity from one single component. Lower cost because we have a single system instead of multiple systems, and it's typically more efficient. Now efficiency is twofold here. The electricity grid, we're processing a fuel at a remote location, and then we're transmitting that energy once it's been generated through a huge grid. And one of the problems with that is there are considerable losses of power as a result, again because of resistance and the things that are going on. So instead of processing shall we say gas, coal, whatever it is at a large power station, what we're able to do here is process gas at the point where it's being consumed, so there's very little loss of energy, unless of course there's any gas leaks, but there'll always be some loss before you get to the point of generation, negligible there. So we're able to produce the energy on demand using this type of system, which would significantly reduce the losses associated with a large grid network. The other advantage is that we have, for example, if any point of the grid is damaged or goes down due to severe weather conditions, that device will continue to produce electricity no matter what. Now of course it does need a supply of gas. However, you can store gas on site or on location. Now fuel cells are actually multi-fuel devices, so they can run off alternative fuels, not only gas but hydrogen being extremely high density energy fuel source. But of course, in the past there have been a lot of concerns over hydrogen, its storage, and how it's managed and handled. Many of those have been addressed now, so it doesn't have to be stored in a gas form, it can be stored in other forms. Anyway, the basic principle behind combined heat and power generation is this: a single device that processes a fuel, typically gas, and during that processing it takes the resulting electricity and heat that's generated to power and heat the home. Or it could be a industrial or commercial building, same process, just larger plant, and the plant here is this device. A mini combined heat and power device is typically used for residential purposes, whereas a plant system is used for larger buildings, whether they be commercial or industrial. Okay, hope that clarifies a few things. Diagram could be larger. I'll try and update this at a later date. Thank you for watching.